On June 15th, 1991, a mountain in the Philippines exploded so violently that it cooled the entire planet, not a region, not a hemisphere, the entire planet, for 2 years. And the way it did that, the mechanism, the chain of events that turned one afternoon of fire and ash into a global climate event is one of the most humbling demonstrations of Earth's power that science has ever recorded up close. You have lived through the aftermath of this eruption. You almost certainly do not know it. Mount Pinatubo had been quiet for 600 years. The people living on its slopes, the farmers and the families in the villages that had grown up over generations in its shadow, had no reason to fear it. A dormant volcano is not a scary volcano. It is just a mountain. 6 centuries of silence is a very convincing argument that everything is fine. In April 1991, the mountain began to disagree. Small earthquakes, steam venting from cracks. Scientists from the Philippine Institute of Volcanology and Seismology arrived to take measurements. What they found was alarming. Sulfur dioxide emissions were climbing fast. The ground was deforming. Magma was moving upward, and it had been moving for a long time, accumulating, pressurizing, looking for a way out. The scientists recommended evacuation. This is, in retrospect, one of the most important decisions in the history of disaster response. Volcanologist Ray Punongbayan led the local monitoring effort and worked alongside United States Geological Survey scientists, including Chris Newhall, whose team had developed a new assessment framework specifically to help predict eruption sequences. Their work in the weeks before June 15th likely saved tens of thousands of lives. Evacuations began. People left their homes. They did not know if the volcano would actually erupt or if they were abandoning everything for nothing. On June 15th, 1991, Pinatubo gave them their answer. The eruption was the second largest of the 20th century. The column of ash and gas rose more than 35 kilometers into the sky. 35 kilometers. Commercial aircraft cruise at about 10. This plume punched through the stratosphere and kept going. The roar was heard as far away as Vietnam. Pyroclastic flows, those rivers of superheated gas and rock that move faster than a car on a highway and incinerate everything in their path, poured down the mountain slopes. Villages were buried. Crops were destroyed. The Clark Air Base, one of the largest American military installations in the world at the time, was covered in ash so thick that roofs collapsed under the weight. More than 800 people died. With the advance evacuation, it could have been hundreds of thousands. But here is the part of this story that is almost impossible to hold in your head. The ash that killed hundreds and buried a base and destroyed entire communities also became something else entirely when it reached the stratosphere. It became a planetary thermostat. Pinatubo injected approximately 20 million tons of sulfur dioxide into the stratosphere on June 15th and in the days that followed. Sulfur dioxide at that altitude does not just drift away. It reacts with water vapor to form tiny droplets of sulfuric acid. Those droplets spread around the globe in a thin, invisible veil, and those droplets, billions upon billions of them, do something elegant and terrifying. They reflect sunlight back into space before it can reach Earth's surface. Less sunlight reaching the surface means a cooler planet. NASA scientist James Hansen, whose climate research spans decades and whose testimony before the United States Congress in 1988 had already brought global warming into public consciousness, was watching Pinatubo closely. What happened next became one of the most precisely studied climate events in history. In 1992, average global temperatures dropped by approximately half a degree Celsius. In 1993, they dropped further still. Crops failed in unexpected regions. Weather patterns shifted. The ozone layer, already under pressure from human-made chemicals, was further damaged as the sulfuric acid particles accelerated ozone destruction. Half a degree sounds small. It is not small. The difference between an average global temperature that supports current civilization and one that does not is measured in single degrees. Pinatubo demonstrated in real time what a single volcanic event could do to the global energy balance. And it demonstrated something else. It gave scientists a test case. A natural experiment conducted at planetary scale. Climatologist Alan Robach at Rutgers University has spent years studying the Pinatubo data, and his work reveals something that cuts in 2 directions at once. On one hand, the eruption proved that injecting reflective particles into the stratosphere can cool the planet. The physics work. On the other hand, it also demonstrated every terrible side effect: disrupted monsoons, reduced rainfall in Africa and Asia, agricultural losses, and ozone depletion. This matters right now, today, in your lifetime, because some scientists are now proposing something called stratospheric aerosol injection as a potential response to climate change. The idea is to deliberately release sulfur dioxide into the stratosphere to mimic what Pinatubo did, to buy time, to slow warming while the world transitions to clean energy. Pinatubo is their proof of concept. It is also their warning. The mountain showed that it could work. The mountain also showed what work looks like. There is something deeply strange about the way this eruption sits in history. It was a catastrophe for the people who lived near it. It was a climate break for the rest of the world. It was a scientific treasure. It was a human tragedy. It happened on a Tuesday afternoon when most of the world was not paying attention, and its effects, invisible, global, 2 years long, touched the air and the harvests and the weather of billions of people who never heard the name Pinatubo. 600 years of silence, then one afternoon, then 2 years of planetary consequence. The volcano did not care about human timescales. The volcano did not care about geopolitics or agriculture or aircraft or science. It simply released what had been building inside it for centuries, and the world absorbed that release whether it wanted to or not. You have heard the phrase that everything is connected. You probably heard it first from someone who meant it in a gentle, philosophical way. But June 15th, 1991 is what that phrase looks like when the Earth means it. An island in the Pacific exhales, and 2 years later, somewhere far away, a harvest comes up short, a winter runs long, a temperature reading on a weather station sits a fraction of a degree below where it was the year before. That fraction is a mountain. That mountain is a reminder. On June 15th, 1991, a mountain in the Philippines exploded so violently that it cooled the entire planet, and the world was smaller and more fragile, and more connected than almost anyone had fully understood until that afternoon when the sky above the Philippines turned black and the ash began to rise, and 600 years of silence finally, violently ended.